Hey y'all, welcome to today's stream. Let me know if my audio is good and if you all can hear me. Don't forget, you need to make sure that you're subscribed to the YouTube channel to use this chat and drop any questions. So make sure that you're subscribed. As soon as you're subscribed, you can start dropping questions in the chat. And yeah, feel free to introduce yourselves in the chat if you have any questions around today's topic, which is going to be jobs in the AI era. Feel free to drop them in. Hey, Ronan, doing good. How about you? Good day, sir. Let me just quickly share my screen and we can probably get started. Cool. Starting off with jobs in the AI era, I think the most common question that I got when I posted about this session on LinkedIn as well was if I had to start again today to crack a role into data science, how would I go about it? Or essentially, if I am a person and who's aspiring to be a data scientist, how would I go about getting into data science? So it really depends upon where you are in your current career. So most folks would fall into one of these two paths. One is sort of they have like a formal education or background in data science or machine learning in some way, shape, or form, like either as part of their bachelor's courses, either as part of their master's courses, or even PhD courses. And then there are others who are somewhat in the tech field but may not be that familiar with programming, that familiar with machine learning, but they're looking to get into AI, they're looking to get into data science. So let's talk about each of these first. Obviously, the folks with a formal education might have a bit more theoretical grounding for getting into data science, and those who are looking to make a career switch may not. So let's talk about bridging that gap first. So, what are the foundations that you need, the theoretical and sort of like skills that you need to make sure that you have so that you can actually land a role in AI? So, I think it's basically four main pillars. One is sort of SQL, and this is sort of the main one that I suggest folks start with. Interview Master is sort of a really good site which has a very comprehensive roadmap that can get you from zero to sort of like a novice slash intermediate level in SQL in a fairly short amount of time. So all the resources that are linked here, I'll drop it after the stream in the description so you can check it out later as well. Um, but starting off with SQL is something that I really recommend primarily because it's a very somewhat easy language to learn because the syntax is fairly limited. And as soon as you get like a few elements of the syntax down, you can actually start solving real problems in terms of like handling data and getting insights from data. So it's a fairly easy language to pick up. It's a fairly easy language to start doing something that actually makes an impact, and it gives you that sense of fulfillment. So SQL is a good way to start. The next one that I recommend is Python. It's a bit more tricky language to learn, especially if you don't have like a coding background. But there are like a bunch of good Python tutorials nowadays. Mosh Programming is sort of a YouTube channel that I recommend, and that's linked here. Again, you'll get it after the session in the description section. So that will sort of help you get started with Python, the basic syntax, and getting familiar a little bit with the code. Once you have a bit of familiarity with the code, it's best to test if you can actually implement a certain functionality. And that's why I've linked a practice set as well, which helps you make sure that you understand like the basics, if loops, if else logic, for loops. You can handle arrays and strings, which are sort of like the common data structures that you typically will come across in sort of like your data science journey. So it's just to test and make sure that you have your concepts down. After that, the next foundation is machine learning. For that, the main person to go to still remains Andrew Ng. His course is free. It covers pretty much all the theoretical foundations that you need for machine learning. And like he always likes to say, even if you don't understand everything, it's all right. You'll get used to it the more and more you sort of work in ML. And then there's an awesome book, Hands-on Machine Learning with sklearn, Keras, and TensorFlow. This will really get you in the weeds of machine learning, developing models in a way that industry professionals actually develop models. So these are the main packages that I also recommend using. I prefer PyTorch over Tensors and Keras, TensorFlow and Keras, but it's really a personal preference. I just started out with PyTorch, so I find it a bit more intuitive to use as well. So, but sklearn and one sklearn for all your basic machine learning, and PyTorch for all your deep learning, or TensorFlow plus Keras for all your deep learning. So that book will essentially help you get started. And then I recommend learning statistics. I don't recommend learning statistics first because statistics tends to be a little bit theory heavy. Um, and just reading through theory without applying anything, I feel like most folks make that mistake of getting into statistics first and then going and learning machine learning, which ideally is sort of like the puritan way of approaching the field. But I feel like if you learn machine learning, if you're comfortable building models, if you see like, hey, I built something that can learn from data and produce insight, and later on, whatever gaps are there in my understanding, I can come back and sort of better understand it by learning a bit more ML theory and bit more stat theory. I feel like as somebody who learned by doing, I think this is a more fun approach. It's a more interesting approach. It helps you stay the path for longer. Otherwise, you just get bogged down with a lot of theory. So I always recommend learning statistics or diving deeper into statistics after you finish your ML. Just to take a pause and see if there are any questions. If you had to rebuild your AI data science career from scratch today, yep, just like we mentioned, this is sort of the path that we are covering. Looking forward to knowing how to narrow my study plan towards AI without having to do computer vision if possible. Yeah, computer vision isn't necessarily like a required field for any of the roles. If it's a role that's focused on CV, sure, it's required, but you can definitely land a role and even build a very successful career without knowing anything related to computer vision. Um, from a non-CS background and previously worked as a Japanese language interpreter earlier this year, I decided to transition into the field of AML. For sure, yeah, welcome to the field. This is sort of the pathway into the field. SQL is the best and most easiest entry point, and then you can sort of build yourself up from that. What about linear algebra? Again, when you sort of get into Andrew Ng's course on machine learning, he'll teach you a little bit of linear algebra. I think that's about all you need if you are hoping to be somebody who's looking to apply ML models to solve business problems. If you're hoping to be somebody who actually builds the next generation of models, you might need a little bit more linear algebra, or I mean, not just linear algebra, but entire like calculus course. But if you're just looking as somebody who's looking to apply and build models, I think Andrew Ng's course covers pretty much all the math, linear algebra, matrix algebra, all of what you need. It's pretty much covered in that course. And our computer vision and CNNs must-haves to get into the field of AI, GenAI research, and jobs of the future. What if I specialize just in NLP moving forward? And at what point can I consider myself job ready? Is CV a required field for the jobs of the future? Not necessarily. A lot of the fields are converging towards that multimodal way of building models, but I wouldn't say CV is required. It's a nice to have, and you can definitely land good jobs just by focusing on NLP. At what point can I consider myself job ready? There's no specific points. If you have 2 or 3 projects on your resume that demonstrate the skill for an applied data scientist, like if you're hoping for an applied data science role, we'll talk about roles in a little bit. So maybe I'll pause taking questions now, and we'll come back to it later. But it really depends upon having 2 or 3 projects that showcases the skills of the role that you're aiming for. At that point, you can sort of consider yourself ready to switch into the application and interview prep mode, which is like a completely different and its own beast, I would say. So after you sort of have this foundation, SQL, Python, machine learning, statistics, then to sort of approach a role in the industry, you need to know a few more things. The first one is getting a bit of knowledge about cloud and building on cloud or developing on cloud or engineering systems on cloud. So being familiar with any one of them, AWS, GCP, Azure, any one of them would suffice. I recommend AWS. I feel like it's the easiest one to approach, and its documentation is really good, and it's always well updated. Like Amazon as a whole has a very strong doc writing culture, so I think AWS docs are very good. GCP I would consider sort of like second best. It's a little bit less maybe intuitive to use. Docs are sometimes you find outdated, but it's also good. Azure, I've used it. I never liked it, but yeah, AWS and GCP are sort of my go-tos in terms of getting into learning a little bit about the cloud. And after that, it's a little bit of ML system design. So that basically means figuring out a bit of Git, a bit of Docker, a bit of Airflow, and also a system design book by Chip Huon, which will also be linked in the slide, which will give you a sense of how to decide your sort of feature engineering layer, then your model training layer, your optimization layer, and then your deployment, different strategies, and most importantly, your monitoring and retraining loop. So all of those things, how do you think about it? How do you actually put a model into production? Considering all of these things, I feel like Chip Huon's book covers all of those things fairly well. So this gives you a little bit more. This gets you closer to being job ready, I would say. I do feel like these are required aspects in the current job market. Having some familiarity with cloud and having some familiarity with system design, ML system design, I think is, in my opinion, is required in the current job market. After this, the most important thing is building out projects. So the kind of projects that you need to build out depends on the role that you're targeting. So whether it's a product data science role, applied data science role, or AI engineering role. So first, let me maybe start by describing what each role is. Product data science roles are a bit more focused on helping improve a business product or some kind of tech product. So it's more focused on causal inference, A/B testing, experimentation. So it's more about helping business make decisions about how to improve the product, like go no go sort of decisions on features about the product. Applied data science is a little bit more about fitting and fine tuning models. So it's about actually building the ML models that becomes the core part of your product. And AI engineering is a little bit more focused about using the new gen sort of soft advances like LLMs, SLMs, APIs to sort of bring in that large language model knowledge into your current business product, tech products, and somehow improve the workflow or improve the customer experience. So each of them are slightly different. They have slightly different skill sets. We have like more information about what each of these roles are and what kind of projects to build for each of them on the Substack. So you can subscribe to Substack and you can get a little bit more info about each of them. But the main one I'll discuss today is like the applied data scientist role. So in terms of applied data science, there are 4 skill sets that you sort of want to showcase to a hiring manager. The first one is fitting and fine tuning a model, which basically means you should be able to, like a model like XGBoost, you should be able to figure out what are its pros and cons and whether it's a good fit for the current problem that you're facing. And if it's a good fit, you should be able to optimize it. So you should know about all the parameters, what parameter does what. If I tune this parameter, what side effects are there, stuff like that. So fitting and fine tuning model, error analysis and improving model. So usually when you go into ML team, they will have ML products that they have already developed. So how do you actually improve those models? You need to figure out where they are underperforming and how to adjust the existing model. You can't just switch the model out with like, hey, I want to switch out this XGBoost model with a deep neural network. No, it doesn't work like that. Most companies have a very complex engineering pipeline that they have put in place. So they don't want to switch out the model all the time. What you're going to do is, how can I improve that XGBoost model? Maybe by developing certain features, maybe by adjusting the calibration mechanism, something of that sort. So error analysis and improving the model is like an important skill set to show. Similarly, continuing from that, feature engineering is an important skill set to show. Almost always in the industry, your improvement in the business metric doesn't come from like a very stunning model. It comes from clever feature engineering, like figuring out what other data sets are there in the company, what can I leverage and use to sort of improve my model. So that's the third most important skill set. And the last one is deploying these models to production. So that's where your knowledge of a cloud, knowledge of Docker, all of that comes in. So there are like different projects that we recommend. Again, it's on Substack, but on high level for applied data science, for example, the first project that we recommend is like some kind of time series forecasting project. This is because forecasting is like one of the most common problems in data science. Almost every company has like one or multiple teams working on some kind of forecasting element. Like even within teams, I would say there's always a member, for, one teammate dedicated to something around forecasting. So it's like a very common problem. It helps you, in my opinion, improve the chances of callback if you have like a time series forecasting project. And it's also a good problem to showcase that you understand machine learning models. Like in time series forecasting, you might start out with models like ETS, Arima, and before you go into your deep profit or any of those sort of models. So it helps to show that you understand these statistical models, where you can showcase that, hey, because of this feature, this feature sort of learning seasonality or learning trend is why I'm getting this kind of metric. So it really helps showcase your understanding of ML methods, understanding of metrics, and understanding of how to iteratively improve models. So I think forecasting is a great project to choose. There are like multiple forecasting data sets. M5 is the name of the competition that sort of sets the benchmark in time series forecasting. So you can check that out. The next project that we typically recommend is XGBoost based projects. This is because XGBoost is sort of like the most common model that you're going to see in the industry. Almost everybody sort of uses XGBoost for every problem, regression, classification, whatever be it. So being able to show that you understand XGBoost and its parameters, and you can not only just fit and fine tune it on a small data set, but at scale. At scale, I mean using PySpark with like hundreds of GBs of data. That really, in my opinion, helps you increase the amount of callbacks that you get. And the last type of projects is anything related to NLP and LLM. This is because of the hype wave that's going in the current job market. I feel just showcasing that you have the ability to handle text data, and you have the awareness of the metrics in the NLP domain, Blue, Rouge, evaluation types like LLM as judge, stuff like that. You're aware of that. Really helps again improve your chance of a callback. So these are like some projects specifically for applied data scientist role that I believe help increase the callbacks that you get when you're applying. So having these products on your resume, in my opinion, does improve callbacks. For each of the other roles, we have like other recommendations on the BuildML Substack. But yeah, I'll take a quick pause here, shift back to the chat and see if there are any questions. Thank you, Ronan. Thank you for the compliments. Always appreciate it. I'm a grad student in CS, switched from engineering in undergrad, looking to get into MLDI, MLDS, AI, and also GenAI. Would you suggest to learn a few things from the latest GenAI developments? From the latest GenAI developments, not necessarily. I would say take a normal path through NLP. Learn the basics of NLP first. Get good with transformers, i.e., any kind of bird-based models, and then working with LLMs is sort of like a different beast. It depends upon the kind of resources you have access to. So I would say just start out with understanding how to write good prompts. Prompts do help improve the kind of context an LLM has access to, and it improves the responses. Once you have a good idea of prompts, which you can get down in like a day, it's not that complicated. Then it's just basically moving on to RAG. Once you have a good idea of RAG systems and vector DBs, then you can look at maybe SLM fine tuning. SLM fine tuning is where you need to get or procure like some kind of specialized hardware. Google Colab Pro is like a fairly reasonable option. So with Google Colab Pro, I think it's like $10 a month, and you get access to a A100 GPU, so that you can use for SLM fine tuning. And you can try out LoRa, QLoRa, quantization, pruning, things like that, and really understand how to optimize these models. In my opinion, with the current way LLMs are improving, I think SLM's reasoning capacity will be good enough that it's gonna become more commonplace than LLMs in 2026. So yeah, I think getting good at SLMs is sort of like a good strategy down the line as well. Yeah, it's something that I'm focusing on and hoping to get good at down the line. As an econ PhD student, how do you think I can get market ready over the winter break? Projects, figure out the kind of role you want to crack, product data science, applied data science, focus on projects. Over the winter break, I'm guessing you have like a month and a half. You can maybe target like 2 projects, try and get those down and put it in your resume. I'm looking for the path of least resistance to get market ready the next couple of months. I don't know if it's the path of least resistance, but it would be the most effective path. What are the industry's expectations from master students candidates? Industry expectation is more around what they need in the team. So it's not really, hey, we're gonna hire a master student. It's more like, hey, we need like a somebody who can do these things like fit and fine tune models and put models into production. So they're not necessarily looking to hire a master student. They're just looking to hire somebody who can do these things. And we have seen like companies focusing less on hiring students per se, as opposed to hiring professionals who can meet certain requirements. So I don't think companies have any like specific expectations for master students anymore. I feel like I have a very strong foundation in everything you talked about, from university course and self-study. How do I show that my resume in a way that I'll get callbacks? Again, we talked about it. Projects are the best way. Match the skill set that the hiring manager is looking for in your project. If it's missing, then the chance of getting a callback is a little less. And again, projects and resume are only 50% of getting a callback. The other 50% is your referral. So make sure you have somebody is not just referring you, but hopefully they reach out to the hiring manager for you. I'll take one more question. I'm currently at an e-commerce platform as an AI intern, which simply connects buyers from local vendors. From which this AI role am I into? I didn't fully understand the question. If you can repeat it, that would be awesome. Thanks, Ronan. Thanks, Lily. Thanks for the compliments. Always appreciate them. I'm from LTI, from Calgary, with a PhD and postdoc in bioinformatics. Awesome. Any tips on transitioning from research into data science roles in healthcare? I think the path again remains the same. It just depends upon where you are in terms of your skill sets. If you feel your skill sets are up to the mark, then where you are in terms of your projects. If you have like 2 or 3 projects on your resume that match the role, then you are job ready. Go for applications, getting your referrals, fine tuning your resume, and applying for roles, I would say. So the user who mentioned, who's from Calgary with a postdoc, just figure out where you are in this journey and you can pick off from there. Cool. Let me just go into the next one, resumes and callbacks. So you have your skills, you're comfortable with building models, you have all those skills, you're comfortable, you have like 2 or 3 projects that you can put on a resume. The next step is, how do I actually write out this resume that will help get me callbacks? So we mentioned that there is like an entire guide on BuildML Substack that walks through how to write a callback worthy resume. But the 3 key points that I think I should sort of like reiterate here. One is how you write your bullets. So that each bullet should help answer 3 things, which is what is the problem, what is the technical solution, or what is the impact. So each bullet, and again I'm repeating, each bullet, you can't split it over 2 bullets or 3 bullets. Each bullet should answer each of these questions. Like if it was building a customer churn prediction model, what technical model did you use, and what is the downstream business impact? All that has to be in the same bullet. It's a bit tricky if you're writing it for the first time to get it in one single bullet. The one single bullet can go into the 2 lines of your resume, but all three have to be present in your bullet to make it a strong bullet. And the next thing that I often see candidates make a mistake on is using model metrics instead of business metrics. That means they're talking about accuracy, F1 precision, whereas they should be talking about things like NPS scores, revenue, ROI, stuff like that, business metrics. Because at the end of the day, hiring managers aren't looking to hire data scientists to build AI products. They're looking to hire data scientists who understand that their job is to improve the business metrics. So if you can showcase that in your resume, then you're more likely to get callbacks. And the last thing that I want to call out is customizing your resumes. I feel like candidates often spend like a significant amount of time changing all their projects and customizing their resumes for each and every JD, especially if they don't know. Like if you have somebody in the company who said that, hey, I'm willing to talk to the hiring manager for you, I'll send them a personal message, etc., etc., then sure, spending a bit of time to make sure your resume is customized makes sense because you have a very strong in at the company. But if you're just applying for a generic role with a generic referral, I feel like you shouldn't spend a huge amount of time customizing your resume. If you do that for every role, I feel like you'll burn out very fast. And I've seen like most of my mentees burn out because of that. So what I recommend instead doing is create themed versions of your resume. For instance, what I did was I had projects mostly in time series forecasting, a bit in NLP, and most of my projects were around e-commerce. So I had one resume that was fully focused on time series forecasting, one that was fully focused on NLP, and one that was a business focused one, mixing time series and NLP, but mostly on ecom problem statements. So whenever a job description came to me, I would figure out which resume matched the best with that job description, choose that resume, and then only change the skills section. In the skills, we sort of mention like the top skills that we have that sort of match the role. So just the skill section I would change, and then I would apply. So this helped me make sure that I was applying for like I don't know, like 10 to 20 roles per day without sort of like burning out. And I feel like creating that sort of sustainable process is the only way to land a job in this market. And finally, yes, you have to apply with a referral. Without referral, the chance of getting called back is very low. Even with the referral, the chance of getting a call back is like in the single digits, in the sense that if you send out 100 applications here, you might hear back from like 3-4 people at max. I mean, not at max, but on average, I would say. So even with a referral, the chance of getting called back is low. So you make sure you do apply with a referral. To get referrals, you have 100 connection requests you can send out on LinkedIn per week. Use that in your connection request, send a message. So the message should be fairly short, 200 to 300 characters. The first line is, hey, I'm just requesting a referral for this particular job ID. Second line is one project, technical detail, and impact, business impact that you had that matches with the JD that mentioned that, hey, because I did this, where I built this and had this kind of impact, I feel like I align well with the role. 2 lines, that's it. I know there are a lot of people who recommend that, hey, networking should be about give, and then take. It's just that on LinkedIn, not everyone is active, not everyone is like a creator. Like for me, maybe that approach might work. Like you're interacting a lot with my content, so I'm more inclined to help you out, sure. But for most of the folks aren't like that active on LinkedIn. So, and most of the folks you ask for referrals won't be creators. So for them, there is no way to give. So the best approach you have is check if they're fairly active on LinkedIn, in the sense that they leave some comments, they have some kind of activity. If they do have some kind of activity, shoot them this message. Then there are other people who recommend that, hey, the first message shouldn't be asking for a referral. This might be because of like more of like I come from like an immigrant background where we have like deadlines like 60 days, 90 days to land a job. um, I do agree that the right way to network is that, hey, start out with a coffee chat, see if you, hopefully you click, and then maybe down the line ask for a referral. But if you're on that sort of like 60-day, 90-day deadline, I would or the approach that I used is sort of like spray and pray, which is like you send out these 100 connection requests a week, and hopefully like 6 or 7 get back to you. And as long as you have a good LinkedIn profile and you're updating it, you're putting up posts, you're have like some kind of activity, you're setting yourself up as an SME in the field, I feel like people are likely to respond. So this was like my approach. This is an approach that I used with few other mentees, and it seems to be working. So this is sort of what I recommend. And apart from this, to make sure you're up to date on field, there are like definitely a few folks that I recommend following. A few of these obviously you might already know. Aishwarya Naresh is like a prior like lead lead applied scientist at Amazon. Zach Wilson, same. Airbnb, Netflix, a lot of top companies. So Aishwarya is a go-to person for most of everything applied data science, LLMs, agents. Zach is a go-to for SQL, data engineering. There are a few other folks that I mentioned on the slide that might be good to follow, especially if you're in that interview prep application sort of phase. And all of them will be linked in the description for this stream after the stream is ending. Cool. Before we go into the next session, let me just go over a couple of questions again. I'm currently working as a backend engineer. Should I focus both on generic system design or specifically ML system design? I would say generic system design might not help you because I'm guessing that would focus a little bit more on sort of like HLD, LLD sort of things, which may not really translate to ML system design. ML system design is slightly different, where you're focusing on the feature engineering portion, the training portion, the deployment portion, and the monitoring and retraining portion. So those aspects is sort of what you want to focus on a little bit more. So it is slightly different. Chip Huon's book covers it very well. BuildML has like has a worked out example of the of a case study. Let me just actually drop that because that's actually a pretty good one. So this is like a case study of the For You page in Instagram. It's a pretty good one. I recommend reading through it to get an idea of what a case study round looks like and what kind of system engineering expertise is sort of expected. Let me actually drop a few more links. This is the blog which covers how to write a callback worthy resume, and this one should cover the applied data science projects that we mentioned. So yeah, these are like again, subscribe to BuildML Substack. It's gonna have like a lot of information. We're writing out interview guides, case study breakdowns, project guides, and a lot more content. So yeah, feel free to subscribe to that. It's gonna help a lot in my opinion. Going to a few more of the questions. Thanks, Ronan. Appreciate it. Hi, I've been following you on LinkedIn. Okay. This semester, I'm looking into retrieval and rec course. Any rec or projects you suggest in the field? I think H&M has like a great data set that they hosted on Kaggle. More importantly, they have like a really good discussion board. So if you go through the discussion board, it gives you a lot of good ideas about what kind of models to build. So check out that. I think that's really helpful in terms of like recommendation systems. In terms of like understanding what state of the art in the field, I think AI Summer has like a good blog that covers what state of the art in the field. I just linked it in the chat again. So hopefully that will help you understand a little bit more about what is SOTA in the field. If in case you need anything else, feel free to drop a DM or grab a mentoring slot on our top mates, and yeah, we can chat more there. Yep, Ron, yeah, feel free to connect on top mate, man, for sure. Mentioned Andrew Ng's course. Do you mean his Coursera one? Yes, his Coursera one. It's also on YouTube. It's available for free. It's also on his deeplearning.ai website, I guess. It's also free. So yeah, wherever you want, you can check it out. I'm currently an e-commerce platform at an e-commerce platform as an AI intern. Which AI role do I fall under or should be targeting in my job search later on? That really depends upon you. If you want to fit and fine-tune models, apply data science. If you want to focus more on causal inference and experimentation, product data science. If you're focusing just on LLMs and using them via APIs, then it's AI engineering. It's very close to SDE engineering. It's just a little bit more focused on system design for using LLMs, their APIs, building out agents, stuff like that. So depending upon what you're doing, what you hope to do, you can sort of define your role. If in case you have any questions, feel free to grab a slot on our top mate and we can talk more about that. Certifications or projects or both? I would say projects first. Once you have 2 3 projects, if you still have time left over, sure, go for certifications. The AWS certification is a good one. I feel it shows you have like cloud experience. Apart from that, I don't have like any specific certifications on top of mind. I feel like deeplearning.ai has a lot of good courses, but not specifically any certifications. Cool. Let's go to what's new in AI. So yeah, what's new in AI? So this is like a segment that I always wanted to do. Hopefully we'll meet weekly and we can go over like updates. Maybe not weekly, but maybe monthly. We can go over updates in the field. So what's new in agents? So just to give you a starting off field, where is agents right now? So we had like the LLM wave with ChatGPT and Gemini and all those models competing with one another, and that led to agents. The idea of the agent being that with LLMs we can better understand our world, and they can sort of make better decisions. So let's give them the power to make decisions and use tools to implement those decisions. So that's the idea with the agent. It's essentially an LLM plus tooling. So that's where we are at, and a lot of companies have been trying to use these agents to solve a lot of business problems. And then what's been happening like in the recent last 2 3 weeks, I would say, is there's been a sort of like there was always an interest in these multi-agent systems where you have multiple agents talking to one another, communicating with one another, and competing and to for a specific goal. Like for instance, if you're planning a vacation, you have a budgeting agent which sort of decides your budget. You have an agent that just is specific to searching for food spots. You have an agent that's sort of figuring out all the activities to do in the area. And these three agents are sort of communicating and maybe at times competing with one another, where the budget agent is saying that, hey, you can't spend that much money on I don't know, cafe, and it's the food agent is coming back with another cafe recommendation. So multi-agent systems has been always around as a theoretical concept. Recently more research has been sort of focused on this area, and it's seeming to gain a lot more traction, and I do expect more news about multi-agent systems being actually deployed in the industry going to come up in the next few months. That's sort of like one prediction I have. The other focus is on memory and planning, and I think this is something that anybody who's in LLMs and who's working on agents right now should be focusing on, which is the idea of the how the memory of an agent is sort of organized in terms of what you give it in the prompt, what you can provide it via RAG, what is stored in the agent via pre-training, and how all of that memory sort of acts as a context for the agent. And this idea of context engineering, as in what should the agent know to sort of answer a specific problem. So if it knows too much information, it can actually get distracted and perform worse on a problem. So we wanted to know just the most relevant things for that problem. So that's the idea of sort of like, or high level idea of context engineering. And we see that actually being implemented in industries right now. A lot of startups are working on this elevation of the idea from prompt engineering to context engineering. And then there's the idea of planning. Till date, like a lot of these LLMs, about how they plan and execute. Essentially, you can think of it as a chain of thought. Like if you ask it to do something, it sort of splits it into subtasks and tries to work through it one by another. If it messes up, it reflects and it tries to do it again. So a lot of these agents had their own planners, but now people are trying to get into those planners in the sense they're trying to optimize those planners a little bit more. So for anybody working in agents, I feel like getting into a little bit more context engineering, getting into a little bit more how planners work and how you can optimize and especially debug and evaluate them, that seems to be an interesting space to work in right now. And last sort of update with the agent field is sort of the increased focus on SLMs. This is the one that I sort of like exploring the most. So LLMs are awesome. They have like extremely good reasoning. They hallucinate still at a high clip. I don't think they're at that space where you can actually put them into industry in a reliable manner. Like as long as you have a lot of guardrails, maybe yes. But yeah, they have like really good reasoning. SLMs, the problem with LLMs, however, is that it's not very cost effective. The ROI, it's very hard to make sense of the ROI for LLMs at times. But SLMs sort of don't have as much reasoning as LLMs, but they're very cost effective. So the idea is, can we actually fine tune SLMs? And SLMs can be fine tuned on a single GPU as opposed to LLMs where you need multiple GPUs. SLMs can be fine tuned on a single GPU in a sort of cost effective manner. And the idea is, can we fine tune them well enough so that we can get good performance on a specific business task? And there are like some cases coming out in the industry, slowly trickling out, that SLMs might be able to do this. Which is like very promising. It's a field like I'm sort of like closely watching, and I'm sort of hopefully building my skill set up for. It's a field that I'm sort of like more hoping will work out, primarily because it's going to shift again the focus from that, hey, let's have this LLM agent that can do everything, and we don't really need any more data scientists or AI engineers, as opposed to, hey, this doesn't make sense cost wise, we need to shift down to SLMs, and to fine tune SLMs you're going to need data scientists again. So I think this space is sort of going to gain traction, and it's a space that I'm looking closely at, building my skill set in, to hopefully ride that SLM wave that I'm expecting to come. Um, and then the what's new in personalization. This is sort of like a related like updates in AI sort of segment, primarily because with LLMs, the main high level domain I think that's getting impacted is sort of the personalization domain. This is because all of the LLMs, not just the large language models, but large vision models, large audio video models, all of these are targeted at better understanding our world. So these are essentially world understanding models, and their goal at the goal of companies at the end of the day is, if we can understand the world very well and the customer's world very well, then we can provide extremely tailored experiences to the customer, which increases their chance of sticking to a product or converting from like a freemium user to a paid user. So all these products are focused on better understanding of the world, and we have been seeing like some use cases like within DoorDash, where they're better understanding their products, using LLMs, using running LLMs on their product hierarchies, and kind of engineering features. So the LLM understands the product hierarchy, LLM understands the customer's interaction. Based on that, the LLM generates features which can then be used in downstream recommendation systems, and it's been shown to improve, at least in cold start user scenario, it's shown to improve performance. So this is sort of like a very promising and interesting space, because it sort of makes logical sense. If you have a model that can understand the world, that can understand customer interactions, then maybe you can engineer features from its understanding and use it in your downstream system. So this is definitely like a very promising space, and something, apart from the SLM area that I'm focusing on, this is like one thing that I'm definitely keeping an eye on. And the other is like the ability to scale content generation, like the ability to not just generate text, but generate images, generate video. These things hadn't been possible, I guess, like a few years back. So nowadays, even though the content feels a little bit robotic and maybe not as human, you have to understand this is as the worst it will be. Like it's only going to get better. So the idea that you can generate content at scale and that content can be personalized to user preferences is really promising. So we are seeing some companies like Netflix, who already did do a lot of content personalization, try and tap into that and generate more personalized experiences. So yeah, this is like maybe another space for folks who are interested, that they can sort of keep an eye on. Cool. Maybe finally, before going into the final section, the future of jobs, let me just take a few questions. Uh, Awesome, Ronan. Yeah, definitely. I don't necessarily think like a master's is required. The brand name of a good college might help you land jobs, but I think even without that, as long as you have good projects, a good referral, you can crack a role. It really depends upon your work ex. I would recommend maybe if you're like absolutely new to the industry, targeting a data analyst role. It's a bit more easier to crack. There are more data analyst roles as well. Working in the data space, building your experience, then looking into applied DS, product data science sort of roles. That could be a path if you're trying to skip master's path as well. Yep. Feel free to send a connection request on LinkedIn. On LinkedIn, my so LinkedIn has like an upper limit on connection, so I won't be able to accept a connection, but I'll definitely respond to messages. Could you drop the link for the Access project mentioned earlier? Yep. I think I dropped the Kaggle link. The Kaggle link is the recommended system project. Could you share the link of the two papers in the multi-agent systems? Yep. Once the session ends, I'll be linking this slide deck, so you can grab the links from there. Next, future of jobs. This is, I guess, the main question that most folks had when I posted about this session. Am I actually going to be replaced by AI? So yeah, tech layoffs is sort of a concern that everyone has. 2022 was sort of like that year where we had a lot of tech layoffs, and surprisingly or unsurprisingly, this month also we are seeing quite a few layoffs maybe across some of the large fan companies. Is it like a repeat of 2022? We don't know. But what are like some trends that we are actually seeing? There does seem to be a trend where entry level roles are shrinking, and companies are preferring, especially larger tech firms, are preferring to hire directly the mid level and senior level roles. I don't know if that trend is maybe going to go away. In terms of how we adapt to that trend, the best bet is to start getting experience via internships. If not, if you can't get experience via internships, aim for smaller companies, mid-tier companies right out of college. Try and land roles there, build up your experience, and then maybe aim for your fan companies. I'm not saying don't aim for fan companies. You can still apply for fan companies, but maybe focus on smaller mid-tier companies first, especially in the upcoming 2026 sort of hiring season. It'll probably start in Jan. I would say aim for those smaller mid-tier companies. Typically, what I've seen candidates do is they sort of use the interviews in the smaller mid-tier companies as like warm-ups, hoping that they land a role in the fan companies. I would say don't do that in the 2026 sort of hiring season. Treat those interviews like proper interviews and try and land them, because we don't know if this trend is going to change. And the other thing that we're seeing, like, hey, are the overall number of job postings going down? That is a bit hard to say. I would say most companies are in this position of we'll wait and see how things play out, in the sense that, hey, is agents and LLMs going to deliver on all the hype that it has? So I'm not saying that jobs are gonna go down or jobs are gonna stay stagnant. I think most companies are just waiting and watching what will happen, and I think 2026 might be the year where we get to find out if the bets on agents, the bets on LLMs are actually going to pay off or not. And the last thing that most people have, like, hey, okay, entry level roles are shrinking, job postings, we don't know if they're going to increase or not. If I get a role now, how do I make sure that I don't get laid off? How do I become maybe layoff proof? Uh, this is again something that's hard to do. Like, I don't think anybody necessarily can become layoff proof. Like, it really depends upon how relevant the business org you're in is to sort of like the overall most important goals of the business. Like, if you're in maybe a non-relevant goal, even non-relevant business unit, even if you're performing extremely well, you could be maybe impacted by layoff. So I don't think it's maybe performance related, but let's assume that you're in a business unit that does really relevant work, that does somewhat relevant work that's sort of important. to the top, to the bottom line of business or to leadership, it's visible. In that case, within that unit, how do I make sure that I have a job? um, I would say that within business, our goal as data scientists is to sort of improve decision making, to improve customer experiences, stuff like that. So when we are building products, we always come across what we call one-way doors or two-way doors. So two-way doors are essentially decisions where we have multiple options. We choose one option. In case that option is incorrect, we can always come back and choose the other option that we didn't choose the first time. So those are called two-way doors. There is no not much ramification. Even if we make the wrong decision, we can always revert our decision and make another choice. One-way door decisions are sort of where if we make that decision, it's going to be very hard or very expensive to revert that decision. Maybe just to give an example, we have an XGBoost model out in production. We want to figure out if one specific feature will help that XGBoost model or not. Adding that feature or not adding that feature, that is sort of like a two-way door. We can try it out. If it works, it works. If it doesn't, it doesn't. We can always revert back. It's not a very expensive decision to revert. But let's say whether we should go with PyTorch or TensorFlow for building out our model, that is sort of a one-way door. Once you sort of choose a tech stack, rolling out of that tech stack is going to be very expensive. Similarly, like maybe choosing between, hey, we're going to build out an XGBoost model in production versus a neural network model in production. The feature engineering pipeline, model monitoring, fine tuning, the expense, all of that for XGBoost versus neural networks are going to be different. So making that choice between XGBoost and neural networks is what we call like a one-way door. So if you are the person in your team or org who makes those one-way door decisions or helps make those one-way door decisions, then you are somebody who's valuable to the company, who isn't really that replaceable necessarily. People who are two-way door decision makers, like even an agent could make a two-way door decision. The agent can just try this out. If it works, it works. If it doesn't, it'll try the other one. But an agent can't make a one-way door decision. If it makes the bad decision, it's sort of very like we mentioned, it's very expensive to revert back. So if it makes a bad decision, it's a huge cost. So in those cases, a human has to be in the loop. An experienced human is a valuable asset in those cases as well. So get closer to those one-way door decisions in your day-to-day, in your business operations. And I feel like that is sort of like the best way to make sure that you can stick around in the company, hopefully. And I know it's like a bit of a vague answer, but hopefully that provides you clarity. Maybe when you start your work week next day, on Monday, think about like during all your meetings, all your conversations, think about all the one-way door decisions that your manager is making, that your leadership is making, and try and get involved in them, try and help them make those decisions better. That would be the best way to approach layoff or becoming layoff proof, I think. Cool. I think that's pretty much all I had in mind to cover. Let me just maybe quickly finish off any remaining questions in the chat. I think we are at 45 minutes. We're almost at an hour. We have 2 minutes left. So yeah, let me just quickly go over any questions. Can you share some products on Kaggle to practice? We have like recommendations on BuildML Substack. So just check the Substack. You'll find more. You can drop me Ronan, you can drop me a DM either on Topmate, BuildML's Topmate, or my Topmate. Like BuildML will forward the message to me. Just mention it's a message to me and they'll forward it to me. Awesome. Yeah, thanks, Ronan. Thanks, Lily. Thanks everyone for joining. If there are any more questions, the session will be, it's a live, so it'll go up on YouTube. After this, make sure that you subscribe to the YouTube, and if you have any questions, you can drop it in the comments, and I'll get to it as soon as possible. Thanks everyone. Thanks for joining. Appreciate it. Bye.